Gupresenta rero turi gupresenta ibikorwa byacu tumaze iminsi dukora muri internship and sharing screen. Kuko presentation ubwayo yanditse mu cyongereza ubwo indimi zombi ndagenda nzikoresha. So this is the art of embedding. First of all, allow me to say that it's an honor to be here, to be able to present to you the mid-internship report of our journey in the art of embedding. So this internship is a team of three. It's Fabiola INGABIRE, who is our team leader, Baptiste, NIYIKIZA, and I, Gabriel, MPUHWEZIMANA, who will be presenting to you today. All of us are from the University of Rwanda, College of Science and Technology. Also, our very best supervisor, Dr. Jean-Pierre Ndabakuranye from the University of Melbourne, is the one who helps us in our daily activities. So going deeper through what we will go through, akanaga kurugato a short story of the background, how it all came, why even the name of the art of embedding. This was primarily driven by our curiosity. So back in the days, I would like also to mention that we officially started the internship 1 month ago, but all the learning and things started in mid-November. So that time we always had this curiosity about what is embedded system. We used to learn the things in class, but it stayed complicated. Tukabona ko byitwa embedded systems, rero niho twakuye amatsiko tugize iyi chance turavuga ngo reka iyi group yacu tuyite art of embedding. And the dream, we had only one dream. The dream was to program the LEDs to spell our names, as we thought it could be the coolest thing we can program as, of course, the embedded system programmers. We had learned to in class, we had learned to like switch the lamps, highs and lows, but we couldn't figure out. So the primary dream when we started, we thought that our supervisor was going to teach us how we can be able to achieve this and program the LEDs, like to spell the name Fabiola or Gabriel. That sounded like the coolest thing we could ever do. But now I can confidently say that now the dream has changed. Today we have already realized that we have already programmed these LEDs that we dreamt about before, and we realized that it is even more possible to dream more than that and explore limitless possibilities in the field of electronics and embedded systems. This is who we are. We normally work in team. We are good team players, of course, and we always do everything in collaboration. We collaborate on various projects, including Arduino devices, Arduino sensor devices, voltage regulators, and more of which I will go through in this presentation. All of us are committed to overcoming obstacles, delivering impactful solutions, and we are committed to keep finding problems and use the little knowledge we get every day, and the more we hope to build in the future in order to achieve these impactful results. And now, let me invite you to join us on this presentation to share. We are going to share our achievements, outline the future aspirations, and of course, share the growth, how the things started, and the project we have been doing through all this time of our internship. Firstly, this is the table of content. We have also already said about the introduction. We will talk about the projects and activities we've done, including the voltage regulator, the Arduino device interfacing, and the skills and growth, because we have learned really a lot. And lastly, it will be the conclusion. Firstly, let me go first and foremost about the projects and activities that we have begun with by the course of this internship. We were able to do the voltage regulators. We worked on 2 types of voltage regulators, and we got a chance to explore the analog electronic circuits, as it was the basic thing we figured out that we wanted to learn by the first time we came here, by the first time we landed on this opportunity. So learning more about the voltage regulators came like a breakthrough. We have learned about the linear voltage regulators. This is the block diagram of this so-called linear voltage regulator we have designed and learned about. As we can see, it is called linear because it uses the Zener diode properties in order to calibrate the output we want to give to our operational amplifier here. This is the Zener diode, which helps us to calibrate the real reference voltage we want to give to our operation amplifier. And this helps us in terms of current gain. It helps us in terms of current limit. This is the feedback we get from the output so that we keep regulating, as this is a voltage regulator, and we take the output from here. Without further ado, let me proceed to other things we have done about this linear voltage regulator. Yes, at the beginning of this project, we firstly had to set up the course of work. Well, by the help of our supervisor, we have learned firstly how to simulate things in LTSpice so that we do things that we feel confident about. So here was the simulation. Here is the circuit board that we built. And finally, we have landed to the juiciest part, which is designing the PCBs. And as I will refer to this after, we are also planning to order these PCBs so that we can touch something that we have designed on our own. These are some of the applications of this linear voltage regulator. They are normally used in the electronic devices that we use daily. I will not go through a lot of that. So the other type of voltage regulator that we have learned about and explored a lot about is the switching mode voltage regulator. We have been also able to compare both of them and see the advantage of each one of them, while indeed exploring the amazing electronics which is used to construct the 2 devices. In contrast to the linear voltage regulator we have seen before, this is a switching voltage regulator, and it is known as a switching because it uses the switching properties of the transistors and in order to regulate the voltage we want at the output. Here we get the AC. We may get any DC input. So here the oscillator help us to change that DC straight into the AC. We have a charge pump in this block diagram, and this charge pump is mainly composed with a diode and a transistor. And from here, this charge pump helps to store the charges into the capacitor, which is located here. All the charges stored here is where we take our output voltage. The remaining of the parts are the overvoltage protection, which I may say like it is like an alert to mention when there is going to happen a problem in this circuit. This is the one which shows us, and the voltage sense in all control systems, we always need to sense the output voltage so that we may be able to feed it back to the input and keep calibrating to get a constant output voltage. We're using the same methodology. We have also started with simulation using LTSpice. We built this circuit on the breadboard, and after that we have designed the same PCB. But this time there was a click that we also learned to use another technology on the design of the PCBs, which was different from the one we have used before. Here we use the surface mount technology. while before we have used the through-hole technology. So this gave us a chance to explore both of the technologies, and it was amazing. The applications are kind of still the same. So it is also used in a wide range of electronic devices, which needs like a minimum voltage. We can be able to achieve 5 volt DC or elevate to 32 DC output by any input that we give it. Let me continue. From this project, we were able to learn a lot about the engineering and design process. Firstly, this came from the way we ourselves, by the help of our supervisor, undertake this project. So we first do the mathematical analysis, which concerns about calculating the measurements that we want. We then do the simulation, the breadboard and testing, and after all, we do the PCB designs. The second thing that we have been able to enjoy and explore about was the Arduino and interfacing. This, I can say that this was like pretty much of the beginning when we started. So we have been able to, it created much of the interest in us to keep exploring. Let me like try to play the things we have tried to work on. That was a song, so it's not necessary that it plays the whole way. So you can feel how amazing we felt being able to read the music from the music sheet and tell the Arduino to play it in the speaker. So that was a milestone to us. In addition, we have also...
ntabwo twayumvishe kubera utarenze audio, ariko icyo ashaka kuvuga ni uko muri design ya mbere bakoze indirimbo bayikina kuri speaker.
Nangaha twagerageje, twari twagize igitekerezo cyo kuvuga ngo ese nko muri feruje ko haba harimo amatara ariko abantu batabona bo bambuka gute. Ariho twavuze tuti feruje zishobora kugumamo amatara ariko hakazaho n'uburyo bw'amajwi wenda bwo kuba bwafasha abantu batumva. Sinzi impamvu wenda bitarimo kumvikana, ariko hano hariho speaker, no kuvuga ngo iyo twatekereje ko iyo itara ry'icyatsi ryatse ryemerera abanyamaguru kugenda, habaho wenda nk'ijwi riri well synchronized kuri feruje, ku buryo n'umuntu utabasha kubona nawe yagira uburyo bwo kumenya guidance mu muhanda. That was pretty much of the things we've done. This was the temperature sensor, and we have also interfaced a lot other stuff on the Arduino. Okay, we learned a lot of practical aspects on the Arduino, which indeed included the measurement and the traffic light control using the Arduino microcontrollers. This came with a lot of hands-on experience, including the circuit analysis, analog discovery. I have learned a lot about using the analog discovery and visualization in different kinds of displays. Here is the third part of it, and I think it's the last part of the presentation, which includes the hand-portable multispectral sensing device that we are currently designing. We are already done with the first version. Now we are designing the second version. This is the block diagram of the device. It is expected that it will contain an optical sensor which shall send the devices on the microcontroller. Optical sensor ni sensor yose izaje ifata signal yohereze kuri Arduino nuko Arduino icomputing ibe ya displayinga ibigaragaye, noneho idufashe no kuba twakwerekana decision. Optical sensor rero dufite hano ni chip bayita Adafruit AS7341 ariyo iri hano display. Iyi display iri kuri block diagram twahisemo gukoresha 7 segment display as the simplest approach we could have taken, and this will be the overboard of Arduino. All these are designed to fit into the Arduino so that we can make a single portable device. This will have a wider range of applications, as I am about to explain about. Ahangaha twari twagerageje kuyikora mu bikoresho dusanganwe, nubwo twageze nyuma tukayikora no kuri PCB. Mu bikoresho dusanganwe twarayikoze dushyiraho liquid crystal display. Aha yari amazi turi gupima ese iyi optical sensor ishobora kwerekana wenda level of it detects the level of intensity of a given color, and we thought that dirty water could have a specific color which opposes to the clean water. So we can by sensing this color of the water, the intensity of the color of water, we can be able to detect the concentration of dirtiness in the water, which is the thing we did here. We thought that this application, we proposed that it could be applied in many places, mainly in the milk market. Sensing the level of whiteness of milk can be used to disclose whether the water was added to the milk before bringing it to the market or not. We also thought that it can be used in the agriculture. Tuvuga ko urabona nk'urugero nk'imbuto iyo zeze ntago ziba zifite greenness isa nk'imbuto zikiri mbisi. Iyi optical sensor rero yadufasha kuba ari aga portable device ugenda ugashyira nko ku mwembe cyangwa ironji, ukamenya niba rikiri green cyangwa ryarageze kuri ya threshold yo kuba twadecidinga ngo rireze reka turikure mu murima. Same as the sensing the chlorophyll level. And finally we have also thought about that this device can be used in sensing the level of biowaste, as we have demonstrated before. Biowaste in the water we use daily, kuko amazi tuvoma ku mugezi ntago aba ari pure tugiye kurebera ku ibara, ntago twabasha kubona niba yanduye cyangwa atanduye. Ahubwo hari icyo bita nano catalyst twabonye ko dushobora kongera muri ayo mazi, noneho zikaba zahindura amabara bitewe na level y'umwanda waba uri muri ayo mazi. From this part, it takes us to the best part of this sensor. We have submitted it for the conference presentation, and it was accepted. So we are supposed to present this device that we have thought about in the conference that we happen through May. It will be an international electronic conference of biosensors. Through the future aspirations, we hope to keep growing professionally. We have plans to start designing using Altium design. Now we use the software called EasyEDA, which is on the students level, but we hope to shift and think bigger by shifting to the Altium design on the industrial level. We hope to keep building devices. We hope to keep searching problems and thinking about them. And after all, dushaka gushiftinga tukareka gukoresha Arduino tugakoresha indi board iri more advanced yitwa STM microcontroller, kuko nayo iri mu bikoresho nabyo twabashije guhabwa nayo tukayiga. And lastly, we have learned a lot about making engineering decisions. That was the coolest part of all the way we have walked through the internship, making engineering decisions which have potential to affect the whole designs. And we are always ready for the positive and negative feedback, because sometimes we can think that we are working, but we have realized that in the working culture, the real work is measured in the real product that we have produced, not the amount of hours that we have spent working. And finally, the conclusion, this internship it keeps getting better, and we keep getting inspired to keep exploring about the embedded systems. And I can't hesitate to thank our very best mentor who keeps supporting us and letting us do all this. Thank you very much.